Hi guys, greetings of the day. I Vijay Vardhan. Welcome you to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 20, which is on hydraulic rotary actuators. Hydraulic rotary actuators are those which converts hydraulic energy into mechanical energy in the form of rotary motion and torque. This rotary motion and torque may be used to carry out works of various nature. Hydraulic rotary actuators are commonly called hydraulic motors, graphically represented by a circle with dark arrows towards the center. A hydraulic motor closely resembles hydraulic pump in their construction. All hydraulic motors have several factors in common. Each type must have surface area acted upon by a pressure differential. The projected areas are rectangular in gear and vane motors and circular in case of piston motors, which you can see in the figure over here. The surface area in each is mechanically connected by an arrangement to an output shaft from which mechanical energy is coupled to the equipment to be driven by the motor. And next, the classification of the hydraulic motors is based on the speed and the torque. We can call it as high speed and low torque motors and low speed and high torque motors and limited rotation motors. Based on displacement, it could be called as fixed displacement as well as various variable displacement. Based on the number of directions of rotations, either it could be unidirectional or bidirectional. Based on the type of freely moving internal element, it could be called as gear, vane, piston, screw, and torque generators, etc. Now let us discuss the first concept called as gear motors. Gear motor consists of a pair of matching gears enclosed in a housing and driven by a fluid pressure. One of the gears is connected to an output shaft and the other is an idler. Gear motors are unbalanced motors. The hydraulic imbalance in a gear motor is due to unmeshing of gear teeth. As the gear teeth unmesh, all the teeth shifted to the system pressure are hydraulically balanced except one side of the tooth on one gear. This is the point where the torque is developed. Larger the gear tooth area or higher the pressure, more will be the torque developed. Fluid pressure forces the gear to rotate. There are two types of gear motors. Based on the method of meshing, they are classified as external gear motors and internal gear motors. Let us discuss the concept of external gear motor. External gear motor consists of a pair of gears of the same size and the tooth from meshing externally, which you can see in the figure. The gears are enclosed in housing and are driven by oil pressure. One of the gears will be connected to an output shaft and the other is idler. Upon working, high pressure oil enters one side of the casing and unmeshes the gears and forces to rotate. The oil under high pressure follows the path of least resistance, which is around the periphery of the inner side of the housing and comes out at a low pressure through the outlet provided on the opposite side of the inlet. The torque developed is a function of hydraulic imbalance of only one tooth of one gear at a time. The other gear and the teeth are hydraulically balanced. The close tolerance between gears and housing help in controlling of oil leakage and increases the volumetric efficiency. Coming to the internal gear motors. In case of internal gear motors, one of the gears with the external teeth meshes internally with the another gear having internal teeth. This internal teeth gear is called annular. There are two types of internal gear motors. Basically, a direct drive G rotor motors or orbiting G rotor motors. We will discuss each one of them. Now, direct drive G rotor motors, upon which we will understand the figure. A direct drive G-rotor motor consists of a set of inner and outer gears and an output shaft connected to the inner gear. The inner gear has one teeth less than the outer gear. The shape of both the inner and outer gears are same and both the gears are in contact all the times. Stationary kidney shaped inlet and outlet ports are built into the motor housing. In this case also both the gears rotate. You can see the figure which shows a direct drive construction of a direct drive G rotor motor. The center of the rotation of two gears is separated by a small distance called an eccentricity, which you can observe in figure number A. The center of inner gear coincides with the axis of the output shaft. And upon working, high pressure oil enters the motor through the inlet port, which you can see in the figure A. Since the inner gear has one tooth less than the outer gear, a pocket is formed between the two internal teeth and an outer socket A. The kidney shaped inlet port is so designed such that once the pocket is full, the fluid flow is shut off with the tip of the inner gear providing a seal, which you can observe the same in the figure number B. As the inner and outer gears rotate in pair, another pocket is formed and the previous pocket has moved around the opposite kidney shaped outlet port, steadily draining the oil in the pocket. This continues and continuous rotation is generated. Reversing the flow reverses the direction of the rotor of the motor. Next, coming to orbiting G-rotor motor. An orbiting G-rotor motor consists of a matched gears, a coupling, an output shaft, and an accumulator or a wall plate. In this type also, the inner gear is also called rotor, contains one tooth less than the outer gear. The outer gear is stationary. The coupling has splines which match with the same speed as that of the rotor. The accumulator rotates with the same speed as that of the rotor and provides the pressure, oil and passage to the tank and the proper areas of spacers. Now figure shows the working of G-rotor motor. Then coming to the next concept, that is called as Vane motor. A Vane motor is a positive displacement motor which develops torque at its output shaft by allowing high pressure oil to act on the rectangular vanes which slide in and out of the slots provided in a rotor spline to drive the shaft. Upon construction, basically a vane motor consists of a rotor, vanes, camring, port plate with a kidney shaped inlet and outlet ports and a casing. Now you can see the same in the disassembled parts of a vane motor and the assembled part on the left extreme corner. The rotor has a radial slot in which the vanes will slide in and out. The rotor is connected to the driven shaft. Both the shaft and the inner hole of the rotor are being splined. The assembly of rotor, vanes and shaft are placed inside the camring eccentrically. Upon working, high pressure oil enters the rotor through the inlet port, acts on the small projected area of the vane, develops force and hence torque. This torque rotates the rotor. As the rotor rotates because of the eccentricity, the vane slides out and resulting in more surface area and more force, hence more torque, which you can see in the figure A and B, which illustrate the concepts of torque development and working of a vane motor. And upon which vane motor will be further classified as unbalanced vane motor and balanced vane motor. Now, what is called as unbalanced vane motor? In a vane motor discussed earlier, there exists two different pressure. One is system pressure and the other one is called as outlet pressure. The system pressure will be greater than the outlet pressure, resulting in side loading on the motor shaft. The side loading is due to only one pair of the inlet and outlet ports. This side loading causes unbalanced forces on the shaft and its bearing results in discontinuous and non-uniform speed and torque. This reduces the efficiency of the motor in particular and that of the hydraulic system in general. Coming to the balanced vane motor, the side loading of the unbalanced vane motor and thereby its effect on the torque can be prevented by replacing circular camring by an elliptical camring, which you can see in the figure A. By this arrangement, two pressure quadrants oppose each other and forces acting on the shaft are balanced, and figure B shows the principle of balanced motor. Such motors are called as balanced vane motors. Since the center positions of the rotor cannot be varied with the center of the camering, balanced vane motors are fixed displacement motors. Coming to the next concept, extending of a vanes. In the case of a sliding vane type pump, the vanes get extended due to the centrifugal force when the rotor rotates. But in the case of a vane motor, the extending of vanes cannot take place by the centrifugal force and create a positive seal between the camering and the vane tip as the vanes are acted upon the pressurized oil. Other methods used to extend the vanes and to create a positive seal between the tip of the vane and the camering. And those methods are a spring loaded of the vanes and the hydraulic pressure loading of the vanes, which we are going to discuss now. Vanes are loaded either by a coil spring in the slot of the rotor or by using the small wire as shown in figure A and B. The spring housed inside the rotor slot is present to the required tension so that the vane is always pushed out of the slot continuously and creates a positive seal between the camering and the vane tip for all positions of the rotor. Similarly, in the case of a wire spring, you can see the figure B, a small wire is attached to the vane is fixed to post. This spring moves along with the vane as it moves in and out of the slot in the rotor. In both types of the spring loading, pressure oil is directed to underside of the vane as soon as the torque is developed. In hydraulic pressure extending method, which you can see in the figure C, oil is not allowed to enter the vane chamber area until the vane is fully extended and a positive seal exists at the vane tip. So this is about the concepts of hydraulic, rotary, actuators. And thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.